This video is for anyone interested in the Flux challenges with regard to flip chip BGA balling. Andy, with regard to flip chip BGA balling, what are some of the challenges for the Flux?
Clearly, solderability is a major one for customers. We have to have very good joint strength, and we have to have no missing ball. That means that the balls have to remain in place where they're placed. Long, consistent usage life of the material, particularly with pin transfer, is critical. And finally, cleanability.
Now, pin transfer, elaborate a little bit.
Pin transfer is where you have a substrate that's probably pretty large. BGA substrates are singulated later on, but the palletization of them can be very large. And when you're printing onto an area that's very uneven, as BGA substrates usually are after the processing steps, it can be a real challenge to print onto them. So pin transfer, which uses spring-loaded pins to transfer the pin from a dip tray onto the substrate, that gives us an opportunity to put flux onto a very non-compliant substrate. It's very important for the viscosity of the material, which is thixotropic in nature, not to increase in viscosity. It's also critical for the material not to increase in tack over time, and that's where our WS575 CRT material is proving very useful over competitor materials.
Very good. How does it work with regard to cleanability?
Cleanability is very important. Customers these days are now asking for room temperature or much lower temperature cleanability. There was a belief that you had to go to higher temperatures for cleanability, particularly with some of the more challenging water-soluble materials after some of the more challenging, more punishing treatments of the substrate. And we've proven using standard techniques such as secondary mass spectrometry or SIMS that our materials are cleanable even again after some of the more challenging pre-treatments of the substrate, so that you end up with a pure copper surface instead of carbon and oxygen being present on the surface.
Where can we get more information, Andy?
As always, go to indium.com or email me at amaki@indium.com.
Excellent. Very informative. Thank you, Andy.
Cool. Thank you.
Take care.
Pleasure as always.
Yeah.